Okay, good afternoon, everybody. Lovely that you've all joined us this afternoon. The first few minutes of the webinar will be myself explaining about the ESSnet project and who we are and what we do. Bear with me if you've been to one of our presentations before, one of our webinars, as this is the same as you've seen at the others. It just gives those people who have not joined us before a little background information about what we actually do. Okay, screen. Okay, so the Web Intelligence Network has been built around the Web Intelligence Hub Hub project, which is taking place at the moment as well. We work hand in hand with ESSnet, helping with the development and the creating awareness of both of the projects. We help with the development of web scraping software for the online job advertisements and online business enterprise characteristics. We're supporting the methodology, quality, and architecture of the statistics produced within the web data even. We research experience, data services such as real estate market, construction activities, online prices for household appliances such as audio, visual, photographic equipment, experimental tourism, indices, business registers, and faster economic indicators using new web data sources. The Web Intelligence is made up of 17 different organisations from around 14 different countries and has over 100 project members, and it's split up into 4 work packages. Work package 1 is responsible for creating awareness of the project, training, promotion and user support, and looking after the wiser group, which is the Web Intelligence user group. The wiser group is made up of NSIs who are not being involved with the project. That will be the Web Intelligence Network project and individuals from academia. They feedback on various aspects of the project, and if you would like to become a member or would like to know more, just drop us an email and we'll certainly let you know more information on how you can actually become members of the wiser group. Work package 2 works on the development of the product environment for the online job advertisement and the online business enterprise characteristics, so data can be integrated into the Web Intelligence Hub and moving the stats into production. Our work package 3 identifies new web data sources within the potential to be integrated with the Web Intelligence Hub. Sorry, I'm tripping all over my words today. And the work package 4, methodology and quality frameworks for the statistics and for statistics to be produced from web data. So if you want to get in contact with us, there's different areas you can join. I said you can join the wiser group. We've got our own website that you can visit, where you can read our blogs. You can follow us on Twitter or X, follow us on LinkedIn, or you can email us on essnet.project@ons.gov.uk. We also have our own YouTube channel where we host all of our webinars that have taken place in the past. If you have any questions today, please go across to slido.com and the access code of #4033102, and you can pop all your questions in there and we'll be able to answer those for you. Okay, so I'm going to stop sharing now and I am going to hand it over to Tobias.
So thanks, Sarah. Let's give this a try. This looks nice, to me at least. Sarah, do you see the slides on screen now?
Yes, I do.
Nice. So first of all, welcome to this webinar about measuring construction activities using data from the web, which means basically gathering data about houses, apartments, and flats using web scraping. And this is joint work within the ESSnet project on trusted smart statistics, the Web Intelligence Network, as Sarah introduced it and described it to you, work package 3, where several groups focus on different use cases. And this is about use case 2. And my name is Tobias Kramlich, and I'm happy to have a colleague at my side today, Alexandra Ilz. And if you have any questions today, please use the question and answer section from the Slido. And Alex will have a look at your questions or comments. So please make use of that opportunity if you have any questions and comments. And well, at least there should be a break of about maybe 10 minutes in about maybe an hour. So we'll see where this will fit into our presentation. So first of all, our team consists of persons from 3 statistical offices. This is my office, Statistics Hesse, and well, me and Alexandra, as well as the statistical office for Berlin and Brandenburg. And I already saw some colleagues joining this webinar today and supporting me and Alexandra. So welcome, Nicole, Andreas. And last but not least, there are colleagues from Statistics Sweden, Per Hammerstrom. Maybe I overlooked him in the list of participants, but Per, welcome to the webinar today. But first of all, I would like to ask you about some information. So what about you? From which country do you follow this webinar? I would like to ask you to go to slido.com and use the code shown on the slide to give some information on your background. So I see we are around 50 participants. Let's see how they distribute about different countries. So still 3 participants typing. Still some votes to wait for. Okay. But it seems that we have the most participants coming from Germany. One happy Germany, that's nice. We have 7 participants from the UK, from Poland, 3 from Luxembourg, Latvia, Austria, Bulgaria, Japan, Portugal, Greece, Wales, Italy, from Switzerland. Oh, that's nice to see that so many people joined this webinar from all over Europe. Thanks for joining today. So I think we are nearly done. So I would like to ask you, before we proceed, what actually is your background and what is your interest in this webinar? So there are multiple answers possible and allowed. So pick whatever options you need, you want to. but it seems that most people are interested in web scraping, mainly in web scraping. As well as there's some background of web scraping. Yes, okay. But we also have some participants that come from the back with the background from construction statistics. So thanks for participation in this survey. But which brings me to the next question. Since many of you are interested in web scraping, still people are voting. But this brings me to the next question. Do you have own experiences with web scraping? So this webinar, it will cover some technical details, but it won't go too deep into technical details. It's a rather general webinar about our use case and how we proceed our use cases goals and the status about our use case. Well, we have some experts, but most of the participants at least heard something about it. Maybe have some own experiences. So thanks for taking part in the survey. Well, this webinar is about construction activities using data from the web. But what do you think? In which areas is or could web scraping be a good tool for data collection in general? Well, we are talking about web scraping in the area of construction activities, and we will see if it is a good tool for in this area. But what do you think? Or maybe what are your experiences? Prices, language modeling. So this does not mean that you must be engaged in these areas or use web scraping, but rather your opinion or your expectation. Risk assessments, real estate, prices, education, agriculture. Or tourism, maybe establishment data, trading training data, press releases, inflation indexes, company data. Actually, there are some other use cases or other work packages within the ESSnet dealing with these topics, using web scraping, experimental statistics in general, energy, job ads, for example, job applications, information aggregation. Well, price. But it seems that prices is the most promising field of gathering information from the web, maybe based on your own experiences. So we use the web every day for buying stuff. And of course, one can gather prices using web scraping techniques. So thanks a lot. Maybe we have, or I hope we have time to come back to this word cloud, maybe for a short discussion, or at least we can discuss it after the webinar with our colleagues within the ESSnet and see how many topics we already cover, or maybe we haven't thought of up to now. So thanks for taking part. So the last question for now, before we start finally, would be, in your office, is web scraping actively used as a tool for, well, any kind of data collection? I know that many offices, they build up experiences and they have solid experiences using web scraping. Many offices are building up experiences and infrastructure for gathering data using web scraping. And it seems that most offices of participants today, they use some form of web scraping to gather some data, maybe prices. Yeah. So thanks for taking part in the survey. So it seems that most of you have some experiences about web scraping. Your office is using some web scraping to gather data. But topic for today, of course, is web scraping or measuring construction activities using data from the web. So thanks for taking part in the survey. And I can switch back to the slides. So remember, whenever you have questions, go to the Slido page and ask your questions or put your comments there, and Alexandra will bring them up. So use case 2 is about measuring construction activities. So what is the official statistics background of construction statistics? So in Germany, there are several official statistics in this area, and among them, there are the statistics on the permissions to construct a building, it's the Baugenehmigung, and this is a monthly statistic. Then there's a statistic about completed buildings called Baufertigstellung, which is a yearly statistic. And additionally, to have a complete picture about buildings, there is a statistic about approved permissions but not yet completed buildings called Bauüberhang, as well as the statistic on Bauabgänge, which means demolished buildings or buildings, parts of buildings that undergo changes in their use from residential to non-residential use or vice versa. So in short, there is one monthly statistic about the permissions to build something and a yearly statistics on completed, not yet completed, or demolished buildings. And typically, our offices report results of these statistics via our internet pages, in reports, in printed reports, PDF files, and with tables organized like this. So number of buildings by number of apartments and energy type, or the number of buildings and apartments by region. So NUTS 1 level to NUTS 3 level, or even LAU level. So that's the typical picture if you search for some numbers in the area of construction statistics. And our use cases goal is to give answers to questions like, can we produce some early estimates of the number of newly constructed buildings? So remember, this was one of the yearly statistics, and the results of this statistics typically gets published in May. And the question is, can we produce some early estimates of this number? Or can we even produce meaningful monthly numbers of the number of completed buildings? Or can we produce some otherwise meaningful number that is related, some additional view on this matter? say something experimental, e.g., for example, new buildings or apartments available on the online market, maybe a part of the complete real estate market. And besides this, in Germany, the new government followed the goal of 400,000 new apartments each year. So one could ask if there's a way of monitoring progress in achieving this goal. So how many apartments and flats have been built up to now? So remember again, there is only the yearly statistics where results get published in May the following year. So one could ask, what is the progress in following this goal? And when thinking on data sources one could use to answer these questions, one quickly thinks about online advertisements, since much of the real estate market takes place online. And everybody, you may know this from your own experiences, one typically searches online for a house or an apartment to buy or to rent. And there are several platforms in your country as well, or portals, where these objects are advertised in a rather standardized way, which means that these advertisements, or more precisely, the structure of these advertisements, looks very similar for all listed objects, houses, flats, apartments in each portal. So what information typically is provided with these ads? Or one could ask the other way around, what information from these ads could be important when thinking about some experimental official statistic based on these ads? First of all, there should be some information on the address, on the location of an apartment or a building. There should be some information on the year of construction, since in our case, especially in our case, we only are interested in new buildings, in new apartments, newly constructed buildings. Additionally to the year of construction, ads often have some information on the condition of the object. If it is new, or if someone will be the first user of it, if it is renovated, if it has to be renovated. But again, we are heavily interested in only new objects, new buildings. And similarly, it is important to know for us from which month an object actually is available for use, which means to live in actually. And additionally, typically the size, for example, in square meters, and the number of rooms is reported within the ad. Typically, a user is interested in the price to pay when one wants to buy or rent a house or a flat. But of course, there can be different concepts of a price, say including or without additional costs, without or with heating costs, and all these different concepts. And finally, one could be interested in special features of an object. For example, whether there already is a kitchen built in, whether there is a balcony, whether there is a garage available, what type of heating is built in, information on the energy consumption of the building, and so on. Or something like whether the building, the apartment, a bathroom is barrier-free and accessible for persons with disabilities. So something like this. And when talking about or thinking about gathering data from platforms or portals, this has a big advantage. And from your own experiences, you know that all pages or ads within one portal, they look very similar. So the pages are structured the same. And of course, the information given in the ad is not always the same, but it is given at the same position on screen, on the page, and in the source code of the page. And this makes it very easy, or in most cases, very easy to identify this location or position within the source code of the page reliably, and to extract this information from this position automatically. And that's all what web scraping is about. And Typically, one can use a method called XPath or XPath selectors to specify a specific position within a web page's source code and to extract the text at this position. I think we have an example or several examples during this webinar, what this actually means. But of course, typically, whenever you are gathering data, typically one have to do some additional data cleaning. So if you are interested in the size, in the living area of an object, you may have to delete the square meter from the living area sizes, or you have to delete euro signs or the word euro from the prices and all this stuff. So that's one approach to gather this information from these portals. Another one could be that from your own experience, you also can tell that information sometimes is given in text boxes, in free text boxes, but the first step would be in principle the same. You identify the position of this text box in the source code using an XPath selector. You extract the text from this text box and then extract the information from these free text using keyword search, dictionary approaches, some regular expressions, whatever, to extract the information you are interested in this rather unstructured format, which information may appear on these platforms. So let's have a look at some examples from Germany. So I just put some randomly chosen platforms on these slides. Well, you can see that's just one example. There's some address given, there's a price given, there's the number of rooms, the living area is given, the total area is given in square meters. There's a free text area, or it seems like a free text box where the year of construction is given. There's some energy efficiency class written somewhere. So that's for one platform. Let's have a look at another one. Well, of course, the ad looks different, but information may be quite similar. Well, the type of the object is given, the type of the house is given, again, prices is given, the date when the object is available for use, rather unspecific at this point, the condition, the number of floors, the living area again, total area, number of rooms, type of heating, some energy consumption information, and again, year of construction. So again, this is rather standardized way of presenting all the information. Well, of course, this is different between different portals. Have a look at a different one. Again, in this portal, again, there's some rather standardized part of the page where information is given. Again, living area, the size of the total, the building, number of rooms, again, construction year, part of the address, price, and again, information given in free text box. Whoops. So all pages within a portal typically are identically structured, but of course, information may be different or even missing. And of course, pages of different portals are structured differently, but typically at least some of the information is the same. So very similar given the nature of the matter. So there will be some information on the price if it's not missing, or there will be some information on the rooms or on the floor an object is located, or some information on the living area, living space. And maybe information is not given directly, but it can be derived from other information. So one challenge when dealing with data, not only coming from the web, but with all data sources, is how to deal with missing data. In our case, this especially applies to the year of construction, since we are only interested in newly constructed buildings. And in our case, well, the year of construction in most cases is given, but sometimes it's not given with the ad. But sometimes the condition of the object is given. Yeah, if somebody will be the first user of the object, if it is newly created. So one can assume that this is a newly created building in a given year. But it also applies to address, since we want to combine ads from several portals by address, and to produce results for several NUTS level, we need some information on city level, at least, to aggregate on. So there should be some information on addresses. And at least in Germany, but maybe you can, well, this corresponds to your experience. Not with all ads, the complete address is given. So this is actually a problem or a challenge. So additionally, if we need to assign ads to a specific month, it's necessary to know when the object actually is available for use. And sometimes this information is very unspecific. In Germany, it often says ab sofort or nach Vereinbarung. So yeah, which is very unspecific, because if I look at the ad next month, it still says ab sofort, but the object should be counted to either last month or this month. So the information ab sofort from now on is not very helpful. And of course, when we want to combine ads from several portals, we need to identify duplicates between portals, matches, but we have to identify duplicates even within portals. But we will come back to this later. So for Germany, for Hesse, Berlin-Brandenburg, we investigated several portals, and there exist many portals in Germany and many sites. And besides others, we picked these portals, and the colleagues from Sweden, they picked a portal which is very common for Sweden. And actually for one portal, there's no scraping, but we have an agreement. So we get data from them without scraping. And I will refer or show examples for their pages. In general, there are bigger and smaller portals. They may be partly specialized on a specific region, for example, or high-end objects. So it makes sense to check different portals very carefully and to test how big is the overlap between them. And it may be quite worth to even scrape very small portals, because they cover a very specific, special part of the population. So when we talk about web scraping within our use case, we talk about weekly scraping. We gather data from these pages weekly, and we identify ourselves to the server, to the portal, to the web page, using a so-called user agent string in the so-called header of the page request, mainly to comply to our own office's web scraping policy. So our office has to decide to give it a policy, and whenever these providers check their server logs, they can see that statistics office, Statistics Hesse, visits their pages and gathers the data. So this web scraping policy links to a specific web page where we explain what we do and why we do this, and why, yeah, what the overall aim is, and what our yeah, why we have to do this. And in general, we try to minimize additional burden by running our program during night or early morning hours. And we only allow a specific number of attempts to get a page. And if I remember correctly, this is only three attempts before we proceed with the next page or ad. We include some breaks and pauses between page requests. So we could be much faster than we actually are, but time doesn't play that big role in this sense. So we include pauses. And we informed the providers that we will scrape their pages. And to give you an overview of what the data we have gathered so far within the project, at least for Hesse and Berlin-Brandenburg, we have 6 portals that we scrape and 1 portal where we have an agreement for Hesse. And as you can see, this is a rather long time series by now, but you can also see that we have some gaps due to technical issues, say redesign of the web page, which made it necessary to adapt our scraper, or simply due to the fact that a person is absent and that was responsible for scraping the page or adapting the scraper. So there are some gaps in our time series. But actually, I think this is quite good source of data for our use case to proceed now. And please note that the sites from Sweden are missing in this overview, but there's data in Sweden on this matter too. When talking about web scraping tools, at first, your browser is the most important tool when starting a web scraping project. At least I think that in my case, the browser is my most important tool when I start a new web scraping project, because you need to carefully inspect the page as shown in the browser, its source code, as well as the network traffic, which means what and how files are transferred to your browser while you request a page to see it in your browser. You check for pagination of the overview pages. You check what information is available from the overview pages without going to every advertisements page. And you already may check for the positions of the information of interest using XPath selectors. And we will have some examples in a few minutes. Your browser is the most important tool, or I think the browser is the most important tool at this stage because it typically has some built-in developer tools, often called, where you can check some more technical stuff. For example, the so-called HTTP headers of your request or the method of the request. We will have examples of this, where you can check for cookies or other tokens that are important and necessary because they are used for authentication to the server, and things that stay typically out of sight to a normal user that just want to see the page on the screen in the browser. So typically when you are requesting, or if you want to open a web page, there are several methods a browser can request a specific page from a server. These are get and post methods. There are other methods, but we will only cover get and post on this slide. And to keep it very short, the get method means that all necessary parameters, for example, search parameters for a house or a flat within a specific region, they become part of the URL that you can see at the top of your browser. So that's quite a typical case. And another method is the post method, which typically allows larger amounts of data to be sent to the server. And typically for example, search parameters, which are sent using the post method, they are not visible in the URL. And additionally, they are not visible or part of a browser history. So that's the main difference. So if we have an example of this, for example, the first one at Immo-Experten, so that's an URL, I can show it to you. That's a very simple example. That's a result page of one of the platforms. Overview page. Well, I searched for objects in Hesse, and I clicked on, well, to the results page number 5, and all this information goes into the URL. So obviously, maybe a 633 means Hesse to this portal, and this page lists all results from the 5th results page. So that's a typical example of a GET request. So what's special about this example is if I have a look at the source code, all the information which is shown on screen also is in the source code. So for example, if I search for, say, this number, this object ID, or this postal code in the source code, then I will find all the information in this rather cryptical source code, which is necessary for the machine to show you this page, but all this information is in the source code. For example, Kelkheim, Einfamilienhaus, it says Einfamilienhaus Kelkheim, object number 275, and so on. Einfamilienhaus Kelkheim, object number. So all this information actually is in the source code. And I can access all this information. But there are other examples. Go back to another example. For example, we will open this page. Oops. That's another portal, ESSnet. It has a very, very long URL. So first of all, there is a GET request, obviously. It puts all the search information in the URL, like this. So I searched again for Hessen. There's a specific ID. Well, I clicked around in the results. So these are results on the 32nd result page. Wow. Results are still loading. Yes, but that's the 32nd page. There are some other information in this URL. Obviously, some sorting order is encoded in the URL. So it looks very similar to the first example, but when I have a look at the source code, you can even see that it's very little text or characters in the source code. And obviously, it's not the same information in the source code. So it's not sufficient to tell a computer or a computer program to specify a GET request using this URL to get the information in this page. And that's the point where you inspect the network traffic flows when loading these pages. We can go back to this. Now we will go back to this example, and you will see that actually there is a post request to a different server, to an RPE that requires an authentication token, which you need to get from another RPE. So it's a little bit more complicated than this example. And the information that is sent to the server is not encoded in the URL, but is sent in the body of the post request. And the actual URL you are requesting information from looks like this. Yeah. but actually there's no information encoded. So if you type in this in your browser, there will be no information on there will be an error message on the screen or something like this, because there's no search parameters encoded. So you have to encode your search parameters as a post request and send it to the server. But we will have an example of this in a minute. So when it comes to web scraping, there are two different approaches. Screen scraping, something very similar to what a person actually would do. And we'll have an example of this in a minute. So you would navigate, or your program, the computer program, would navigate through a portal like a person. So you open a starting page, enter some search term, region, for the objects you are interested in. You get a page of results by region. You get several results pages by region. Well, then there's a separate page for each object. And you will extract information from each page, page by page, which means inspect the HTML source code of each page, identify the position of the relevant information using these XPath selectors. We will have an example in a minute. You will clean the data, for example, using regular expressions, clean your data using string functions, and we will have a look at this after the next slide. The second approach uses an RPE, an interface to the data, application program interface, so an interface to the data, and typically you will not notice that you are using an API, but you can see this when you're inspecting the network flows, and where you search for documents in a specific data format, say JSON format or so-called XHR request. So that's quite typical for this kind of requests. And again, it may be necessary to prepare a HTTP header in a specific way, or send even a post request to get access to the data via the RPE. But we will have an example. But when you get the data in this JSON data structure, typically you have to clean this data as well to get it into a table-like structure. And we will have examples of both. And common to both approaches is a thorough knowledge of the page you want to scrape. So typically you have to carefully inspect the page themselves, as well as the network traffic that comes with them. Well, and typically this means a lot of images, a lot of JavaScript files, map tiles, ads that you see on screen. So that's, but actually also the data we are interested in. So let's stay with the first example, with the screen scraping. I put the pictures over there. So we start at the overview. Well, you start at the start page. You put in a search term, for example, Hesse, then you will get result pages. In this case, there are a lot of result pages. We'll have it bigger on screen in a second. And finally, you would open up all the separate ads to extract the information. So we can have this example by hand. When we go to Immo-Experten, just go back. Just open the start page. In this example, Hessen. I leave all these options unchecked because I want to get all the results, which gives me the first result page, which says 532 ads at the moment for Hesse. For this portal, I have to use another URL I already showed to you. So I have to start not with this one, where Hesse, the search term, goes into the URL, but I use another URL which has been shown on the first result page. And now I would extract all the information given on these pages. And I would have to think about looping over all these result pages. Obviously, there are 53 result pages. So I have to go through all these pages or tell the program to go all through these pages. So the first exercise would be, how could you determine the number of necessary iterations for this first loop to get all the result pages. So if you know this number 53, you could produce all the URLs by yourself or automatically. So 53, yeah, or 11, 12. So your computer program could all generate all these URLs automatically up to the last one and extract the information necessary for the next steps. So we will use the built-in tools within the browser. So whatever browser you are using, chances are that there are these tools built in. In my case, it's called Untersuchen. Sometimes it's called developer tools. So check your browser. It's Untersuchen. And I use Firefox. And I want to extract this number. So is there a way to tell the computer, please tell me this number? So I have to specify or tell the computer, go to this position, wherever it is in the source code. Yeah, I can close this. Wherever this is in the source code, please give me this number. And is there a way? And of course, there's a way to tell we are interested in this number. Yeah, so this is rather technical, HTML source code. And if you inspect the source code for a while, you will see that this is a table actually. And there's division, there's an unordered list, and then there are list elements. And you are, we are interested in the last number, but not in the last list element. The last list element is this sign. We are in the second last list element. So we want to extract this number. So what to do? So it says table, then there's a division. So this is if you want to do web scraping, you will get, or you are familiar with XPath, and that's rather cryptical, but it's an XPath notation to extract or to specify a position in the source code. So this is table, division, this is an unordered list, then it's a list element, the last list element, the second last list element, and there's a typo, dann kopiere ich's. Oh ja. It's the following sibling, So there's a table element in it. Next to this table element, there's this division element. And beneath this division element, table element, on the same level, there's this division element. So it's the following sibling. Under this division element, there's an unordered list. Then there are these list elements. And we are interested in the second last list element and the text of this second list element. Oh, and I forgot the anchor element. So there's an anchor because it's a link. And this is the text of the link element. And that's the way how to or would be a way to write down an XPath to extract this number. And as soon as we have extracted this number, our computer program could generate all these overview pages automatically in order to proceed with the next step. But these overview pages in this example, they contain a lot of information. For example, they contain some ID number, they contain some address, they contain the number of rooms, they contain the living area, the type of object, and the price, if it's an object to rent or to buy. So we could even start with extracting information from the overview pages. So let's have at least 1 or 2 examples to extract information from this overview page. Let's start with, for example, the object ID. So we need the object ID to maybe check if we gathered data for the same object at a later page. So let's see if we can find the object ID within our within the source code, and we will see that this is located within a table structure. Then it's bold text. It's within a bold element. This is the first bold element within this table structure. And we are interested in the following sibling. And which should be a text. So, and actually this is true. So if you are familiar with XPath or get familiar with XPath selectors, this won't appear as cryptic as it may appear right now. So the point is that when you have the source code on page, and if you have inspected it carefully, you will be able to extract a lot of information from this overview page. And this was the example of the object's ID number. Say, well, what about the address? Well, we could use the address. It's quite similar in this case. It's quite easy. This is the second element. And you already see it marked over here in the source code. Again, it's the second bold entry in this table element. But we are interested not in the bold element, but the following sibling, an element on the same level. And this actually is a text element. So we have to specify that we are interested in the text. And this is true for all these entries in the result page. Well, of course, there are many ways of writing down these XPath selectors. So there could be an alternative, not using the position. For example, this 2 over here. But as we know from inspecting the page, it's always written like this: Adresse, double point, and then there's something following this Adresse double point. We could also write it down like this. So there's a text written in bold, which is Adresse. And again, it's the following sibling. And again, it's text. So again, this one is marked, and this is the information we want to extract. And we want to extract it from all the entries on the overview page. But actually, we are interested in the link to the individual separate advertised page. So, well, one of the tasks would be to extract this link information. And this by inspecting the source code, one would see that this is, well, we can check if we can find it. Well, there's a tool. Well, and by inspecting the source code, we will see that this is again hidden in a table cell, in a table row, in a data cell. It's the second element of the table cell. It's an anchor element, and we are interested in the href attribute of this anchor element. So we would tell our computer program, please extract all these elements and all these information for all the advertisements listed on this page. So that was for very, very, very short an example of the screen scraping to tell the computer or a machine to do something a person would do actually. And I will show you a second example, a somewhat more complicated example.
Tobias?
Yeah.
Not to interrupt you, but we have also 2 questions in Slido.
Yeah.
Would you like to answer
Okay.
them?
Ja, jetzt muss ich suchen. Oh, the first one is easy to answer. With Immobilien Scout 24, we have an agreement, so there's no scraping with them.
But we also never scraped their website at all, right? Or did we have some experience in trying to scrape it?
Actually, I don't remember because a colleague of mine started this project, and especially scraping maybe also Immobilien Scout, but I don't think so. Maybe, yeah, I think there was an experiment using the newsletter functionality, but we stopped this actually, and there was an agreement because they actually sell their data to everyone who is interested in, which has some advantages to compared to scraping the data. I can't tell anymore, honestly.
Yes, but I think also the newsletter option was quite interesting to just have an email sent to you every time new buildings were advertised in Immobilien Scout, and then from the email you could see what is new. But of course, this is not a perfect method.
No, but it's. I think it's an interesting way. Maybe I'm not sure if it's the way to go, but you can specify your search profile and you can register as a user, and then they will send you all the advertisements you otherwise would search using your browser. And typically the email comes in an HTML format, and you can use this as input for your data cleaning procedures as every other HTML document. So yeah, I'm not sure why we didn't follow this. I think we had the chance to get this agreement with them. Yeah. Is your answer is your question answered? So there is no scraping actually with Immobilien Scout. Is it necessary to have a permission to scrape a website? I, on purpose, have excluded all these questions about is it legal or can we do this or are we allowed to do this from this webinar. So I think I think that's something to discuss with your legal department actually, and to check your office's regulations if you want to do this. So our office, we have checked and we have talked to our legal department, and we think that that it is okay to scrape these sites. So there are some barriers that you are allowed to overcome, but as long as you don't have these barriers, it is okay. But that's the decision of our office, and you should check with your office actually. And maybe the opinion may change, and or the circumstances may change. So I think it's not possible to answer this in a general way if it is necessary to have a permission. Maybe if there's some time for discussion. No, actually, I excluded it on purpose because there are so many opinions about this and so many different experiences about this. In our case, it is not necessary to have a permission. But actually, we informed them that we are scraping these sites, and we don't hide our origin. So if they check their server logs, they can see that we are coming from a statistical office. Yeah, we don't hide ourselves. I think that's quite a good policy. Yeah, we shouldn't hide what we are doing. And as long as they are not obliged to do something, someone can decide not to provide the information, then that's fine. And we give them the chance to do so. Okay. Okay. So good. Then I may return to the slides.
Yes.
Oh, okay. The second example, it's somewhat more complicated, and I think I will cover it only shortly. That's an example that incorporates a post request, including a token to send back to the server in order to authenticate. And this token, additionally, this token is only a valid specific amount of time. So it's a little bit tricky. And the colleagues of Berlin and Brandenburg, they took care of this example. And Per Hammarström from Statistics Sweden, he came across a solution when we ran into a problem, so that this was joint work. So in general, it looks very similar. Like the example we already had. So we open up a page, a start page, where you can type in your region of interest, say Hessen, and there's a proposal of Hessen Bundesland, which is very nice. So we can get results for the federal state of Hesse in one step. And then on screen, well, actually there's a GET request with some search parameters in the URL. And so that's the first result we get. You can see there are some parameters in the URL. So technically this is a GET request and we get results on the page. But I already showed you that when inspecting the source code of this page, there is not much information in it. So we have to take another approach. So, but the first thing to note that there's information. There have been 6,607 objects for the search. There are 321 search pages. And again, this would be very similar to scraping, the example we had. But as I showed you, there's no information in the source code of this page. So there's a lot of cryptic stuff, but nothing in it. So we have to inspect the network traffic and network flows in much more detail, because when we look at this page and the source code of this page, there are no results. But if you use the network traffic analysis tool built in your browser, you will see that a lot of files are transferred to your computer. When you open this page, of course, the images have to be loaded. A lot of fonts have to be loaded, downloaded. Some style sheet information has to be loaded. Some JavaScript files have to be loaded. But you will see, and by checking some of these files, you will see that there are some requests to some RPE, to some different servers, to some RPEs. And one of them is this token colleagues have discovered, and I have rebuilt for this webinar. And we will use and need this, this information. First of all, you can see this is a GET request, but we don't get the information we need. But there are some POST requests over there. And again, if we have a look at the result, at the source or preview of this page, there's no information in it. But if we check other files that have been transferred, we will see, well, interesting, there is actually the data transferred somehow to our browser. Maybe I can show this. I should show this to you. So I used the built-in developer tools this time, the network analysis tool. I refresh the page. First of all, this is a GET request. Well, all the information is given in the URL. No, not untersuchen. But as I told you, there's no meaningful information for scraping at this page. But if you search through these files that get transferred to your computer, you will stumble across something like this. Ooh, interesting. It says a number 6,642 results. Oh, this looks like the number like this, and 333 result pages. Oh, this looks very similar to the overall result pages. Well, what is hidden over there? Ooh, that's interesting. It looks cryptical, but Mehrfamilienhaus in blah, 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 Darmstadt. Ooh, interesting. So this exactly is the data we have on screen. And it's the data in one file. Yeah? So the question is, how can we access this file and request this file from the server instead of this one? And this is, if you go back, oops. So obviously this is it is a POST request, and we can check what information is in the body of the POST request. I don't want to go too much into details, but these are the search parameters. So I search for objects, for sale objects, for houses, a lot of other information. That's the location. Obviously, Hesse goes into the 121.732. That's information that should be encoded in the body of the request. And after some while inspecting the pages, well, colleagues stumbled across this authorization token they have to send in the header of the request itself. So that's something you have to rebuild for your scraper. Question would be, well, where to get this token from? And after searching these files again a while, you will see that this token is transferred to your machine with another request to a different RPE. Oops. And as a result of this request, you would get this access token, which is then resent to the server. Oh, it's lost. Which is resent to the server in the header of the second request. So that's something you have to rebuild when building your scraper. So I put it on the slides, and I put a screenshot on the slides. You may have to adapt the HTTP header for the content length. depending on the body of your request. So, for example, if you're, well, that's typical stuff that you can copy and paste from from your analysis of the network flows. So, well, search requests, obviously this worked. So I just copy all these headers and put them into my these headers and put them into my computer program, into my scraper. Maybe I'll adapt the user agent. I also copy the payload, which means the body of the post request. Maybe one has to adapt the page because you have to loop over all the result pages. So this was result page 32 with an offset. So for the next one, you have to specify 32 at this position, starting at 0. And it may be the case that you have to adapt the content length of the HTTP header. So, but I didn't want to go too much into detail. I can give you the proof that this actually has worked when we have a look at the microdata. So that's all interesting, but what we are really interested in is the actual microdata. So for example, from our screen scraping example, to go to back. From our screen scraping example, remember we had the overview pages that listed all the advertisements. At the overview page, where we extract the links to the individual ads, but already can extract some information about the individual objects. So the ID, some address information, if given, the object type, the price, whether the object is for rent or for sale. And in some situations, this may already be enough information to stop scraping here. But actually, we continued with all the individual objects pages like the next one. The resulting data set looks like this. So that would be a data set resulting from scraping only the overview pages. And that could be simply enough. So it's a list of 544 objects in Hesse scraped at September 15th. These are the individual link URLs we didn't visit anymore, or you may not have to visit anymore because you are happy with the address, the type, and the price of the object given at the overview page. But actually, we didn't stop, but we went for all the individual ads. So there was a second loop that went over all these URLs extracted from the first step. And remember, we extracted prices, the condition, number of floors, living spaces, and all this stuff. And the data set actually finally looked like this, much more columns. So this was scraped at September 28. This was the individual URL that was scraped. There's the extracted object ID, the type of object is given on the page, Dachgeschosswohnung, whether it's for rent or for sale, then the price, depending on if it's an object to rent or to buy. Maybe there was a fixed price when the object is for rent. Then there's some information specifically given when the object is for sale, information on heating costs, additional costs, some amount you have to pay if you want to rent the object, since when the object is available, ab sofort. I told you this is rather unspecific, but given the point in time, the date of scraping, this may be meaningful. The condition, neuwertig. I think we are interested in newly built buildings. So Erstbezug, first use would be the objects to go if there's no construction here available. Then there's the floor, the living area, and so on. But there's even more information. We stopped at living area, the total area, number of rooms, number of bathrooms, number of sleeping rooms, if there's a garage, what kind of floor is in the object, what kind of heating, and so on. So that's the result of the actual microdata. Well, looking at the time, I actually skipped our break, but decided to tell you at least so. Or Alexandra, should we have a short break?
Maybe you can answer another question about API documentation, and then we can go for like a 5-minute break.
Yeah, okay. So I
people can get coffee, stand up for a bit, and then come back.
Yeah, that's a good way to go.
Yeah.
And I can answer the question very short. Yeah, I think it's detective work actually, and there are colleagues in the list of participants. Maybe they can support my view. Many of these RPEs aren't documented, as long as you aren't the customer actually. I'm not sure if the RPs are documented in this way. Sometimes RPs are documented the other way around. So if you want to advertise many objects, there's an RPE to put many objects and to manage many objects through an RPE. So there's a documentation for this way. But I think in our case, there was no documentation of the RPE. No, unfortunately. But this may change actually. So in this case, I think it was detective work. And it was joint detective work because, as I told you, the scraper was broken at some time. And I think, if I remember it correctly, it was joint work of the colleagues from Sweden and Berlin-Brandenburg to fix it, because they just noted that this token that was necessary to resend to the RPE is valid only 30 minutes with one portal, but 60 minutes with another portal. So this was kind of detective work. Yeah. And if this answers your question.
Yeah, in the meantime, we got another question about code.
Yeah, I can show it to you. I'm not sure if it's very, I can show it to you in a minute. But maybe after coming back from a short break. Yeah. Would that be okay? So I would suggest that we meet in 5 minutes.
Yeah, and then when we're back, you can, or do you want to answer another question? Because I think this is a short one for you.
Okay. Another one, yeah.
Yes,
sure.
yes.
Okay.
People are very interested. Great.
Yeah, nice. So we will see us again in 5 minutes. See you soon. Okay. Okay, so welcome back after a short break. And we stopped with the question, if I am going to show some code I use to extract the data elements. Well, first of all, I remember I showed some of these XPath selectors, and that's most of the work actually of the code. But of course, I can show you code. But please be aware that's just proof of concept. That's not actually how we did it in our project. So we distributed our responsibilities for different portals. And for this webinar, I just rebuilt these two examples for the post requests and more complicated example, and the easy one, the screen scraping example. But I can show you some lines of code, but I don't, yeah, I'm a little hesitating a little bit because I'm sure it's not the best way to do it. And it's not something actually productive. Yeah? But I can show you the principle, of course, and that this actually worked. Yeah? That was one of the questions. And the second question was, have you used ChatGPT to web scrape? No, I haven't, and my office haven't, as far as I know. I would like to ask you, what are your experiences? Or do you have experiences using ChatGPT? Or do you have you used it for code review or actually gathering the data? So maybe you find some time, some seconds to write it into the Q&A section, what your experiences have been. So that would be quite interesting to hear. I have to keep track on to time and the slides. So I want to show you that this actually worked. So, well, I did this, I rebuilt this in R, but there are several tools you can use, and I'm sure that this is not the best way and the most smartest way to do this. But as I told you, I started with, well, we start with the complicated example. It's much technical detail, but you ask for some code. I had to rebuild the header, yeah, to send to the server for the post request. So I built the header. I just copied this from what I saw over here, yeah, when I had to get this token. Yeah, there was this header, request header, and I copied all the stuff I found here. Yeah. So I put this in my R script and the functions that are available with all the 7 million packages. And I decided for one, and I built this header. Then there is a body I have to send. Yeah, that's the payload. And in this case, it says grant type client credentials. So I copied this actually. That's my body I have to send to the API. Then I can perform the, oops. Oh, ich muss erstmal alles machen. Header, body. Then I can make the request. I can check the status code, which is 200, which means, okay, HTTP status code. I can check the content. Well, there was an answer in JSON format. I can extract the content. I extract some, well, we can have a look at the response. Well, I don't think that it's very helpful. I extract the information, the token. I have to do some data manipulation in order to make it look like this. Token, bearer. That's what the server expects to answer the post request. I can remove all the unnecessary stuff, and then I can make the actual post request I'm interested in. First of all, I showed to you this was the second request to this one. Again, there was a body, for example, for the 32nd result page. The search parameters are encoded in the body. There was this header. Again, I copied all the header fields, but I made sure that, or our colleagues, they made sure that this bearer token actually gets always the actual value from the first post request. So one has to rebuild this. So first of all, the body. I check the content length of this body because it may change. Yeah. So it actually measures this content length, measures the size of bytes of the content of the body. And well, this may be the same for the first 10 pages, 9 pages, but with the 10th page, the content length would be different. So I thought it would be a smart idea to calculate this automatically. Content length, some data manipulation that the content length for the header field looks like this. Then I could create the header. This should look like this. This was exactly the same like the browser would send. And then I could perform the page request to this RPE, where we finally got the response, our JSON data. Yeah. Check the status code, 200, which means okay. And actually there was an object in JSON format. And I start to extract some information. Yeah. Selected page, so this was the first page, so the selected page is 0. Total count of pages in the recent request is 586 result pages. So there are 20 elements within each overview page. So I can decide on the number of loop iterations necessary in the next step. And that's it actually. Then I have to, which means 30 iterations have been necessary. I have to extract or get the JSON structure into a table-like structure, add from which overview page the information came from. And let's have a look at the resulting data. So that was the example of accessing these RPE using 2 post requests to 2 different RPEs. I decided to not go into detail, but since one of you asked, that was a very fast example of how I did this and rebuilt this just for demonstration purposes for this webinar. That was the first example. Next step would be to do all the requests to all these subsequent overview pages. Yeah. 3.2. Oops. So that would be the next step, to run a loop over all these result pages. So that would be example for the more complicated one. And the data extraction for the screen scraping is very similar. Well, I told you I started with this page, which is actually this one. And the well, that's just it's very simple. Just read the page, ignore the warnings. Well, it's just for demonstration purposes. Read the data and use the R functions to extract XML data from an XML object, specifying all these XPath selectors for the link, for the object ID, for the address, as I showed you before, for the type, for the price. And that would be the information that could be gathered from the first overview page like this one. So that's Offenbach, 1.5 Zimmer apartments, room apartment. And this is Offenbach. Well, it says 1.5 room apartments. The object ID is the same. The price is the same, should be the same at least. Oops. 140,000 euro to buy. So that's just simply writing down the XPath. So if you are, well, if you are want to do web scraping, you will get familiar with writing down these XPath selectors or CSS selectors to identify the position of a specific information in the source code of your HTML page. So that's all the magic behind. And actually, it's not very magical. So it's a lot of detective work actually, but it also makes it's fun. Sometimes it's fun. But again, there would be a loop over. Well, that was the first result page. I showed you how to extract the maximum number of loop iterations. So we would go to the second result page up to the 53rd result page. So there would be a loop to loop over all these result pages where we extract all these individual advertisements pages. And again, there would be a second loop that loops over all these URLs and extract the information of interest. In this case, again, maybe address, price. No, that's not true. Heating costs, additional costs, the condition, number of floors, the living spaces, number of rooms, what type of floor, what type of heating, and so on. Year of construction when given on the page. So that's only a matter of specifying the correct XPath. So that's the whole magic behind this. So there's nothing special with this. So if there's some time left, we can go back to this at the end, but I still have 5 slides to go. And Sarah wants to close the session, so I have to hand over to her again. So, but of course there are some challenges. As always, we may face missing values and we have to cope with them somehow. And in our case, in many cases, parts of the address is missing since the information is not given in the ad. So someone does not want to reveal the exact location within the ad. So you have to get in contact with the provider or the advertiser. But typically there's information on the city district or the postal code level because users typically search for objects in a specific area, say at least city district or postal code. But actually missing address information is a challenge when it comes to deduplicating ads or combining ads from several portals, of course. Then there may be different concepts behind some characteristics, even when the information is given in the website. It may mean something different. for different objects or different portals. I mentioned the different concepts of Miete, rental prices, so without or including additional costs, with or without heating costs. Living area may be something different or different than the total area of the object. So one has to take care of extracting and comparing similar things or things with the same concepts. And of course, it may be true that the other way around, that same characteristics may appear under a different but similar name in another portal. So having in mind combining and comparing data from several portals, it may be a good idea to decide on names and types of characteristics of your final data sets in advance. And even if this means that some columns in your data set never get filled, or get filled only from one specific portal. So that's one lesson we have learned. So by now we spent much time in harmonizing our data sets after scraping. So let's talk about results after scraping. A first useful aggregate to build and to compare with our official microdata could be a data on street level. For example, it may not be possible to decide whether 2 or more ads at the very same address are indeed duplicates or refer to different objects. And it may be the case that in many cases there's no complete address information, but only information on the street name, but not on a house number. But this could also be a meaningful aggregate to look at and to compare with our official statistics macrodata, if allowed, actually. So it may not be allowed to keep the addresses of the official statistics microdata. So typically we report aggregates, say, by different NUTS levels. So we could build aggregates by these levels and compare results to our official statistics. So there's no linkage of microdata on detailed address level, since this actually may not be allowed or not possible. And especially combining data as well as aggregation typically includes a lot of data cleaning. So for example, see the list of the city names from one of the portals, the city name of Frankfurt am Main. So there have been 25, well, I don't know, maybe 25 different ways of writing down Frankfurt am Main in one portal. And typically, but that's nothing new to you, typically it's very hard work to clean your data before starting combining data or analyzing data. And that's true with web scraping too. Let's have a look at example for multiple ads at the very same address. So start at this example from one of our portals. We have 5, use this one, we have 5 ads at this address, Flörsheimer Straße in Hattersheim-Eddersheim. This could be 2 duplicates, which means the same objects, or these ads may refer to different objects. So let's have a look at the satellite image. Well, doesn't look suspicious to me. This seems okay because the picture could be outdated and there might be a new building now, and the area looks large enough to hold 5 or more apartments. So nothing wrong here. Could be a hint that these 5 entries are no duplicates. So let's have a look at the scraped microdata and compare information given there. And well, these are all different separate objects. In my opinion, they have different prices. They share a lot of information. They are all objects to buy or to sell. Free from December 24. All new, located at the same floor. No, the building has 2 floors, but they are all located at different floors. They have different sizes, but so these look like separate objects to me. So nothing wrong with this. So at the end, let's compare some aggregates from 2 portals on postal code level. So that's from one of the portal, that's the screen scraping portal, that's the more complicated portal. And I just built aggregates on postcode level, and I sorted the table according this column or according this column. And interestingly, there's very low correlation between these 2 tables, which is some kind of hint to me that these are different objects, and there could be good reason to combine these two portals into one data set. But of course, still, you have to be sure that that there are no duplicates after combining these two tables into one. That would be one way to look at this data. But where to go next? Well, we have to compare the aggregates between our portals. We combine the microdata from our different portals. This includes the duplication within each portal and between portals. And then we can again compare aggregates from combined portals to our official statistics. And at the end of the year, well, very simply said, we sum up all the ads for all new buildings that appeared in our scraped data during the year. And we will see how close this number is to the next year's publication of the official statistics. Remember, we have this yearly statistics on Baufertigstellung, completed buildings, which appears in May. And we will have a number at early January, where we can sum up all the ads that appeared in 2023 for newly constructed buildings. So that's a very short, not so short, but a very fast overview over our use case and the methods we use, some experiences we have. Before I hand over to Sarah, and maybe we can come back to another question, I would like you to answer a last question on the Slido. If I manage to start it. Yes. I would like to ask you, what do you think after this webinar, or even before this webinar? What do you think? Is the field of construction activities actually a good field for web scraping? Maybe based on your experiences from this webinar or from your expectation in general, despite attending this webinar, or from your experiences outside this webinar at all. So numbers, yeah, are changing. But it seems that a majority sees web scraping as a tool, maybe a helpful tool for gathering data in the field of construction activities. But maybe the situation for some of you is different, or the situation regarding access to the portals is different, or your office policy may be different, or legal requirements may be different, so that this is not an option. Or the information is not given on the websites, typically. So I leave this open for another minute. But I can come back to you.
There were also, sorry, before you hand over, there were also 2 other comments regarding ChatGPT and another web scraping tool.
Okay. Alex, but I don't manage to show it on the screen.
No, I mean, yeah, I can. I mean, it were just comments. One person said that ChatGPT can be useful. However, I would not trust 100% its code and statistical understanding based on past experience. And I would agree with that. I think it can be very, it can give you ideas, but I wouldn't blindly copy and paste. And of course, always be, you know, yeah, don't give up sensitive information into ChatGPT. And the other one is a comment that I thought was interesting. The person said that Kadoa is a tool that uses AI to make web scraping easier. I have never heard of it before, but yeah, it might be interesting for some people in the audience to, I don't know, maybe simplify their workflow to get ideas. So Kadoa is the program that is suggested by the person.
Thanks for this hint, yeah, and this comment. Kadoa, interesting. Okay, thank you very much for your comments and questions. So thanks for your attention and remarks. Thanks to Sarah for your support, excellent support. Thanks to you, Alexandra. Thanks to my colleagues, our colleagues from the other offices, Per, Nicole, Kerstin, Andreas, Holger. And yeah, well, again, thanks for your attention and have a nice afternoon. And I'm happy to answer another question. But first of all, I would like to give the chance to hand over back to Sarah.
Right, guys, can you see my screen?
Yeah.
Right, lovely. Okay, just to let you guys know that our next webinar is on the 23rd of November, and it's all about new avenues with web intelligence, gaining additional value from cash registered data by combining different data sources. I will send out a link for people who would like to join us on that one. Also, it's I want to ask to remind you all to complete our survey that we will be sending around. I've just put the link into Slido as well for you. You can click straight onto that link to be able to see. It's a mixture of 12 questions. I honestly say to you, it'll take you about 5-10 minutes to do. And it's very important to us to know that what we are delivering, how we're delivering it, is right for you guys, right for the audience, because at the end of the day, you guys are important to us. So yes, please complete the survey. As I said, this is being recorded and we will send around a link to everybody. And I will also give you a gentle reminder to do the survey in the link. So once again, thank you for joining us today. Remember to do your survey, and I'll hand back to Tobias to see if there's any more questions.
I'm not sure if there are any more questions, Alex. So
not in Slido.
Not in Slido. So thanks for attending this webinar. Remember to take part in the survey, and thanks, Alex. Thanks, Sarah.
Thanks,
have a nice
Tobias
afternoon.
And Sarah. Thank you, everybody. Bye.
Bye, guys. Have a good afternoon.
Bye.